Let's evaluate the definite integral from minus 10 to 10 of the square root of 100 minus x squared. Now, so far in Calculus 2, we learned the technique of finding these definite integrals by first finding an antiderivative of the function we are integrating. And once, let's call this antiderivative capital F of x. Once we found it, we then take the limits of integration, in this case from minus 10 to 10, plug it into that antiderivative and get our answer. So the answer would be capital F of 10 minus capital F of minus 10. The problem is we're not able to, so far in Calculus 2, to find antiderivative of this function. None of the techniques we learned so far can help us do that. Later in Calculus 2, we're going to learn an integration technique called trig substitution, and using that technique, we'll be able to find an antiderivative and then proceed just as I indicated here. But at this point, we can't do it. So there has to be another way of evaluating this definite integral, and that way is to look closer at the function that we're integrating. That function is y equals the square root of 100 minus x squared. If I square both sides, y squared becomes 100 minus x squared, and I move x squared to the left, x squared plus y squared equals 100. Now you should recognize this as a circle whose center is at the origin, that is 0, 0, and whose radius is equal to square root of 100, which is 10. Now if we work our way backwards, solving for y squared and then solving for y, notice that we have a positive square root. Positive square root indicates that we have an upper semicircle centered at the origin of radius 10, and we can now draw that semicircle. Here's what it looks like. This is minus 10, this is 10, and also this is 10. And our integral that we're asked to evaluate is from minus 10 to 10 of the square root of 100 minus x squared, and that is precisely the area underneath the semicircle above the x-axis. In other words, it's the area of a semicircle of radius 10. The area of a circle of radius 10 is pi times 10 squared, so semicircle will be 1/2 pi times 10 squared, which is 100 divided by 2, 50 pi units squared. So we're able to evaluate this integral by recognizing the function that we're integrating and then understanding that that's just the area under the function. The integral is the area below the function above the x-axis. That happens to be the area of a semicircle. We were able to do it without integration. For more videos, go to www.mathprepvideos.com.